In this lecture, we continue with the study of non-homogeneous equations and the method of undetermined coefficients. However, in this part B here, we'll consider cases where the initial guess, capital Y, does not work. And because of that, we will need to modify the guess for it to work. In order to see what is going on, let's look at an example. Example 1. We want to solve for a general solution the following ODE: y double prime plus y prime minus 6y equal to 2e to the 2x. As usual, this is the non-homogeneous equation for the problem. As we have seen in the previous lecture, in order to solve a non-homogeneous equation, we need to begin by solving the corresponding homogeneous equation. Which means that we have y double prime plus y prime minus 6y equals 0. We need to use characteristic equation. Let me just write out quickly the characteristic equation, but you should be able to solve this. We have r squared plus r minus 6 equals 0. You may use quadratic formula, you may factor, and here are the two values. One is 2 and 2 is negative 3. So we have the case of two different real roots. So y1 is e to the 2x and y2 e to the negative 3x. That's the first step. Solve the homogeneous equation. Now the next step is to guess the formula by educated guess and find capital Y of x. So how do we guess this capital Y right here? So let's look at our g again. This is g of x. This is a constant multiple of the function exponential e to 2x. It's twice of the exponential e to 2x. So as before, we will begin with our guess. Capital Yx is also a constant multiple of e to the 2x. So let's try to find the derivative and then plug in the equation, the non-homogeneous equation. We have 2a e to the 2x, and then y double prime will be 4a e to the 2x. Now we plug into a non-homogeneous equation, which I'm rewriting here: y double prime, then plus y prime minus 6y equal to 2e to the 2x. Second derivative is 4a e to the 2x. First derivative plus 2a e to the 2x. And lastly, minus the function, minus 6 times the function, which is 6a e to the 2x, equal to 2e to the 2x. As before, we'll divide through by e to the 2x to cancel this out. And what we get is 4a plus 2a minus 6a equal to 2. and we are trying to solve A. But in this case, if you simplify, what we get? What do you get? 6A, 4A plus 2A, 6A minus 6A becomes 0A equal to 2. What is A? Well, we cannot find A. Because 0 times A must be 0, cannot be 2. Or if you think the other way, you could say, well, divide A will be 2 divided by 0, which of course doesn't make any sense. Right? So we cannot find A. So what does this mean here? We cannot find A. What it means is that our guess capital Y x equal to A e to 2x is wrong. It's not a correct format for capital YX here. Now recall from the previous lecture, for exponential function, we began with this guess and it worked. But what happens in this case? Now most of the time, such a guess will work, but in this case, the difference is that if you look at this function e to 2x here, we're guessing capital Y equals to a constant times e to 2x. But if you look back at y1 and y2, e to 2x happen to be the same as y1. Right? This part right here is same as y1. So let me explain why it doesn't work. So A, Y, what happens when it doesn't work? Well, we guess capital Y to be a constant multiple of y1. But what is y1? Y1 is a solution to the homogeneous equation. Right? This y1 is a solution to this. So in no way that a constant multiple of y1 would solve the non-homogeneous equation. Because y1 solves the equation equal to 0. So you cannot solve the equation equal to something different from 0. That's why it doesn't work. Right. So because y1 solve homogeneous equation, so anything like this, A e to 2x will solve homogeneous equation as well. And it cannot solve non-homogeneous equation. So how do we modify for this to work? This is the rule here. So if we have a guess for capital Y, and it happens that in the guess capital Y, there is a constant multiplied by either y1 or y2, then we need to modify it. Modify by, this is an important fact, we need to modify by multiplying by x. And that's all. No adding any other terms. We need to just multiply by x. So let me recall, this is initial guess. For this problem, capital Y is A e to the 2x. And let me just remind you again, e to x here is same as y1. Now, if it is not the same as y1 or y2, then the guess will work. You don't modify. But in this case, it's same, so we need to modify. Yes, by multiplying by x, meaning that we should have A x is the 2x. This is the guess we should look for. Knowing this, we can take derivative. A is a constant. Use product rule. We have e to the 2x plus 2x e to the 2x. Second derivative, 2e to 2x here, plus we have product rule, 2e to the 2x plus 4x e to the 2x. You should pause the video and try to do the calculation yourself here. Simplify to 4e to 2x plus 4x e to 2x. Now we have all the derivatives. So let's plug into a non-homogeneous equation. We need to begin with second derivative, which is a 4e to the 2x plus 4x e to the 2x plus the fourth derivative, which is right here. So a e to the 2x plus 2x e to the 2x and minus 6 times the function. So 6a x e to the 2x. And on the right hand side, we have 2e to the 2x. Now do the algebra. Distribute and collect like terms. We have 4a e to the 2x plus 4ax e to the 2x plus a e to the 2x plus 2ax e to the 2x and then minus 6ax e to the 2x equal to 2e to the 2x. We will try to simplify things. Collect like terms, and the like term we're looking for are terms with like e to the 2x alone, and terms that has x e to the 2x, x e to the 2x, x to the 2x. But you can see that we have here 4a x e to x, and then plus 2ax e to x minus 6ax e to x. So these can cancel out. And we have left with 5a e to 2x equal to 2e to 2x. And now we can solve for a by dividing both sides by e to 2x and then divide by 5, we have 2/5. So we have found capital Yx is 2/5 x e to 2x. Don't forget the x here because that's our new modified guess. So put everything together, we have the answer, which is the general solution to our non-homogeneous equation. That's C1 e to the 2x plus C2 e to the negative 3x plus 2/5 x e to the 2x. Okay, so what is the rule here? Always we need to follow the method that we discussed last time in the previous lecture. We begin with our initial guess for capital Y and then check if we have a constant times Y1 or a constant times Y2 in our initial guess, then we need to multiply that affecting part by x. And once we have a new guess, we can solve. Let's look at another example. Example 2. Solve the equation ODE here. Y double prime plus 2y prime equals to 2x. This is our non-homogeneous equation. So to solve this, we begin with the corresponding homogeneous equation. Y double prime plus 2y prime equals 0. Using characteristic equation, you need to be careful with characteristic equation. Double derivative, we have r squared plus 2y prime will give us r. And solve by factoring. R times r plus 2 equals 0. So we have r equals 0, which is r1 here, and r2 is negative 2. And so y1 is e to the 0x. But e to the 0x is the same as e to 0, which is 1. And y2 e to the negative 2x. Now we need to guess and find capital Yx. Let me rewrite the equation. Y double prime plus 2y prime equal to 2x. And remember, we have a polynomial. For polynomial, we should fill in all the missing terms, missing powers by putting 0. We begin with the highest power of x, which is power 1, so 2x. Missing constants, so we should fill in 0. Now, our initial guess. This is g of x here. What is our initial guess? We will have ax plus b. So actually this is a times x plus b times 1 as before. We have x to the first and then x to the 0, which is 1. That's the initial guess. Now let's check if any of these things the same with y1 or y2. If they're not the same, then we are good. If one of these is the same, then we need to modify. So look back at y1, y2. Well, we see that 1 is the same as y1. This is same as y1. So we need to modify by multiplying by x. We need to modify by multiplying by x. So we would have v times x. What about this? Ax here. Well, we cannot keep it the same because then it will be the same as b, the like term with b times x. So it's like a domino effect. If we multiply this one here by x, we need to do the same thing and multiply this by x to get ax squared. That's what we need to do when we modify polynomial. If we multiply the last thing here by x, then we need to do multiply the higher powers of x by x as well. And we don't add anything else. Okay, so keep in mind, modifying the guess means multiplying by x, and that's all. No adding anything new. Now take the derivative. We have 2ax plus b, and take the derivative again. We have 2a. And let's plug into the non-homogeneous equation. So we have second derivative, which is 2a plus 2 times the first derivative, which is 2 times ax plus b. On the right hand side, we have 2x plus 0. Distribute and then collect like terms. So we have 4ax. I'm writing the terms with x first, and then we have the constant 2a plus 2b left equal to 2x plus 0. Now we equate the coefficient. 4a is a coefficient of x should be the same as 2. So we get a is a half. And then 2a plus 2b should be the same as 0. We get 2 times a half plus 2b equals 0. So from here, we saw that b is minus a half. So capital Yx is a right here, ax squared plus bx. So we get a half x squared minus a half x. And then the answer, general solution, y c1 y1. But remember, y1 is 1, and then c2 y2 e to the negative 2x plus capital Y, which is a half x squared minus a half of x. For this example, we don't have any initial condition, but if we do, then we need to use initial condition to determine y1 and y2. So far we have seen two examples. The first one was exponential function. The second one was polynomial. Now the last one here was trigonometric function. So solve the following equation. Y double prime plus 4y equal to 4 sine of 2x. This is a problem in the homework actually. So as before, we need to solve the corresponding homogeneous equation, which is y double prime plus 4y equals 0. So characteristic equation, be careful, a square plus 4 for what? Just 4, because it's y, so no taking the derivative, so we don't have any r. In this case, we have r squared equal to negative 4, so r would be plus or minus square root of negative 4. We have plus or minus 2i. So y1 and y2. Plus or minus 2i, so they 0 in front, right? 0 plus or minus 2i. So we don't have the part right here, so no exponential. We only have the imaginary pieces. And the coefficient of I is 2, so y1 will be cosine of 2x, and y2 is sine of 2x. No exponential because of this 0. So let me rewrite again. This is alpha plus or minus beta I. That's the case where we have complex number. Alpha is 0, so no exponential. Now the second step is to guess and find capital Yx. As before, let's look at G. G is 4 times sine of 2x. It's a constant times sine of 2x here. So our guess, when we have trigonometric function sine of 2x, our initial guess would be a times sine of 2x. But remember, once we have sine, we should have the companion cosine to x as well. But this case will not work because of we have a constant times sine, which is y2, and even worse, b times cosine, and this is y1 as well. Will not work. You may try, and it turns out you won't be able to solve for a and b, but we don't need to waste time doing so. We know right away that's going to work. So the modified guess is that we need to multiply the affected term by x. So here we have the same with y2 won't work. We need to multiply by x. So ax sine 2x. Similarly, bx cosine 2x. This is our new modified guess. Take derivative and plug into non-homogeneous equation. Now it will take some time to do this, and you may check the solution posted on Blackboard. So I won't do it here. I'm gonna just write down the answer for you. You could try yourself. When you take the derivative, don't forget the product rule and also the chain rule, because sine 2x, cosine 2x here. The answer turns out that a is 0 and b is -1. So capital Yx is minus x cosine 2x. And so the final answer, final solution to non-homogeneous equation is that y1 at y equal to c1 y1, which is cosine 2x plus c2 y2 sine 2x, and then minus x cosine of 2x. This is the answer. Okay, so in the rest of the lecture today, I want to discuss a little bit more general situation when Gx is more complicated. It's a more general case for Gx. Remember that the equation that we are trying to solve is a y double prime plus b y prime with cy equal to g of x. Now so far, we have seen g of x is either a constant multiple of exponential or polynomial or trigonometric functions, basically sine or cosine. And for each case, we have an initial guess for capital Y. And if the initial guess does not work because it's coincide with y1 or y2, then we need to modify by multiplying by x. But this may happen that gx is more complicated. What if gx is a more complicated, like exponential multiplied by, say, like this, is 3x cosine 2x? Is the product of two things, exponential and cosine. So what is the initial guess we should have for capital Y? Well, for exponential is 3x, our initial guess would be the same e to the 3x, right? But for cosine, we need to have both sine and cosine. So for this problem, if gx is like this, then our initial guess would be a e to the 3x cosine 2x plus b e to the 3x sine of 2x. Of course, calculation of the derivative and then solving for a, b would be complicated for such a problem. So I will just discuss a few cases here. You won't see this in the homework, but for your better understanding of what's going on. So if we look at another case, say g of x is say x squared e to the 2x, then what should be our initial guess? Now, I'm just writing down the initial guess, but we need to check, right, if the initial guess has part of has y1 or y2. If initial guess has a constant times y1 or a constant times y2, then we do need to modify. Now here for this example, we have a polynomial x squared and e to 2x. As before, for polynomial, we need to fill in all the missing term. So we should have x squared plus 0x plus 0 here, e to the 2x. And once we have that, we will guess capital Y in the same format, ax squared plus bx plus c e to the 2x. Now c, if we have something like 3x squared sine of 2x, then what should be our initial guess? You may pause the video and try to write out yourself. It's a polynomial. We need to write to fill in other terms with coefficient 0. So we would have ax squared plus bx plus c sine of 2x. But because of sine, we should have the companion cosine with the same format. So over here should be d x squared plus ex plus f. So you see that it's quite complicated here because we have 6 coefficients to be determined. Again, this is just for your better understanding of what is going on. We won't do such a problem. And this is the end of the lecture.